which interval is this function positive? Yeah. Here I think there is not really any calculus involved. You just need to do some analysis on the function. See when it is going to be positive and when it's going to be negative. Well, a good point to start at is to ask, when is the function going to be 0? Because if it's 0, it's not going to be either positive or negative. And from here, this is not too difficult to see that 0 is a root for the function. So it's one of those points where the function is not positive, it's not negative, it's just 0. You just plug in 0, you get 0 over pi squared, which is 0. So this is what I mean. And that is already a good start. But then you would like to know which parts of the equation control the sign. What do I mean by this? Well, you have a numerator, you have a denominator. Can we say something about the numerator? About how it behaves? Is it always less than 0 or greater than 0? I mean, yes, it is always greater than or equal to 0. So how do I say this? Yeah, here's how. So if you have something that's always positive, or 0, then you need to have something that's always positive or 0. So if I want this to be greater than 0, then I also need the denominator to be greater than 0. Because if the fraction, the top of the fraction is positive, and you want to get something that's positive, you need to divide by something that's positive. If it's negative, then it's going to be negative. So what I want to say here is that this pi squared minus x squared is what controls the sign of this expression. The sign, I mean by this positive or negative. So I'll just remove the words and I'll write that if this is greater than 0, then probably this should be greater than 0. And if this is greater than 0, how do you solve it? A good way to do that would be to set the equation to be equal to 0 and try to find the roots of this, meaning you would find the asymptotes, the vertical asymptotes of this expression. But then I'll save you some time. This is the difference of two squares. So I can write this as pi minus x times pi plus x. Now if I want this to be greater than 0, then I either want these two terms to be positive or these two terms to be negative. And so that's already very important. If I want this to be positive, and this one I want it to be positive, then I need it to be, I need my x to be between minus pi and pi, right? Here's why. Because if I solve this as a normal equation, I'll get that x is equal to pi and x is equal to minus pi. So I don't want to say this, and this is very bad, but if you solve the inequality, if you solve the inequality, you need to be careful. with what you need to list. Is it greater than, or is it less than? Is it less than, or is it greater than? So that is not determined. So maybe we need another line, but this line would be just for this function. So this function, maybe I'll call it g of x. And I would like to see when g of x is greater than 0. So I know the roots of g are pi and minus pi and pi. And then if I want to inspect how this function behaves in the middle, then I probably want to plug in a value in the middle. And the best value to plug in the middle is 0. So if I plug in 0, I get pi times pi, it's pi squared. But I don't care about the number itself, I care about the sign. So this is true for any number that is in between minus pi and pi. If I plug it in, I get positive value here, I get a positive value there. So that's amazing. And if I plug in for a value that's less than minus pi, if it's less than minus pi, then it's probably negative number, so this is going to be positive. But if it's less than minus pi, it means it's more negative, so this will be negative. And so this will be also negative. And you can check by similar argument that this will also be negative. And so, in that case, we would like x to be less than pi and greater than minus pi. So you see what we did there? It's very important. Okay, then if we take a look at now the bigger function, which we would like to have be greater than 0, then you have minus pi and pi, and you know that this is positive, but when this is positive and that is 0 on top, then it's just 0. And so the answer would be minus pi to 0, and then you take the union of that with the open interval, which does not include 0, to pi. So I believe there was a mistake with the worksheet, because in the choices, the closest answer to this is from minus pi to pi, but that is not true, because the function is not positive at x is equal to 0. So that is the caveat here. If you don't take care of the roots, then you might make some mistakes. And that's why it's very important to watch out for that. So this is incorrect. Incorrectly stated in the worksheet. It is now corrected. But if you chose this answer, then you get the full points. So that is enough for this video.